In September 2009, the Moon Mineralogy Mapper, which was a team that I was on, sponsored by NASA, and it was on the Indian orbiter, we were the first to find water on the moon. And when we did, I got calls from all over the world, not from major countries, but from third world countries. I got a call, for instance, and I swear to God this is true, from Costa Rica, and they asked me, do you have any lakefront property? So naturally, that cartoon that I sent you that has that lakefront, okay, that was the reason why we came up with that, because we all laughed. We're talking about water, but we're still talking about parts per million here, parts per million there. You're not going to be able to pick it up and do that. You're going to have to extract it from the soil in some way. We found water in the moon, on the moon, and I make a distinction between that which comes on the moon, that's which comes from comets and from solar wind hydrogen and all sorts of external processes. We call these exogenic. And then we also have now more proof for things that are in the moon. In other words, in minerals, apatite, some normally anhydrous minerals that we find. We're now finding parts per million water, hundreds of parts per million. People ask me why I'm studying the same rocks for 40 years, how I can make new discoveries. And I tell them that every 10 years I can look at the same rock, I have new mind to look at with, but more importantly, I have new instrumentation. Instrumentation is evolving at such a fast rate that, I tell kids, hey, back in Apollo days, I didn't have a pocket calculator, Now you've got them to throw away. And the fact is, we didn't have the types of sophisticated instrumentation. The Earth has water, but see, the Earth was hit by this supposedly giant mass, about the third of the size of Mars, that we call Theia. And Theia was supposedly the predecessor to what most of the moon is. Okay. Now, supposedly this was dry, and also because of this giant collision, the outermost portions of the envelope of material that developed around the Earth that was furthest out was the driest of all material. And so that's where the moon formed, and the moon was bone dry, and that fit with all the theories. Now we have to come up with an idea that maybe both the moon and the Earth, at about the time of the formation, were bombarded by heavy amounts of cometary material. Now, this cometary material wouldn't affect the Earth because the Earth had lots of water, so it wouldn't affect the signature so much. But on the moon, a little bit of cometary water goes a long way, so it would affect the signature. So much of the signatures we're finding on the moon are cometary water signatures. When our ancestors were moving into a new part of the world, they couldn't bring everything with them, so they had to learn to live off the land. That's the way it's going to be when we go to a planet. It takes $25,000 to take a kilo of water to the moon. Okay, that's an awful lot. But now we have a lot of permanently shadowed craters on the moon which contain hundreds of tons. It's been estimated on the North Pole alone 600 million tons of water. That's enough to make 1.2 trillion pints of Guinness. Okay, now just think if we had that. Not that we could drink it all, because we don't need it so much for drinking, but what we do is we split it apart. We get hydrogen and oxygen, and those are our two major rocket fuels. So when we leave the Earth, 85% of our mass is gone because it's rocket fuel. We get to the moon, we got an empty gas tank. Okay? We come up and we fill up with our hydrogen and oxygen. We now have a filled gas tank. We can go boom, we can go to Mars, we can go wherever we want. So it could be a gas station in the sky. I've been proposing that for 20 years now. So it's a likely place that we should go to.